All right, hello. So we just finished recording Discord pipeline. All right. So what we just done was in this databases, we just populated league matches data table here. So all of this data from seasons 1 to 6 extracted from Excel sheets and Discord. We pulled all this information. At the same time, for each matches, we also created this jobs table that has replay URL for each job, right? So we have the S3 key and we have the league match ID, relation ID, and all that. All right, and we also have the state. Cool. So that's what we did in the last two pipelines. All right. So what this video is going to be about is on this run, scrape, replay pipeline. And what this does is that it's going to go through each job. All right. So each job here is going to go through each replay JSON. No, it's going to go through each job here. And through the league matches ID, I'm going to be pulling the replay URL, right? So I'm going to be pulling the replay URL for each job. And that's going to be right here. So for each replay URL, I'm actually going to make a request to that replay URL. We're going to have to bypass CAPTCHA so that we could get the JSON data from these replays. And once we have that data, we're going to verify that that's the data that we want. I'm going to show you how I did that. And then afterwards, I'm going to load that JSON to S3 because we're going to be using that data a bit later. All right, cool. And what S3 is it's an object storage through AWS, Amazon Web Services. It's on the cloud. All right, so basically think of it as like instead of saving these JSONs or instead of saving files on your local machine where you might have things that might be a bigger scale than your local PC can handle, or you just don't want it on your local PC or whatever you want to have on the cloud. S3 is where you would store that. All right, cool. Alrighty, so let's go back to our folders here, and we're going to go into our what's it called? Run replay parser. All right, so this is the pipeline for that. I'm going to brief it again, but all my pipelines follow this similar format. It has this run pipeline function. This is our entry point function, which gets called here. All right, and then this run replay entry point kind of function. Let me look at this real quick. Actually, okay, interesting. This is not it actually. We're looking at scrape replay. All right. So in this scrape replay pipeline, I have this pipeline function. Same thing. I have this run pipeline function, and then I'm going to take the sessions, or rather, let me skip that. I'm going to give it the resources that it needs to go through each job. I want to extract the replay JSON from the replays, and then I also have these. All right, so this is actually more complicated. So I actually have a concurrency manager here with AO meter. This whole pipeline is going to be asynchronous, all right? So you have async IO, you have AO meter, and HTTPX, which is going to be our HTTP client. It has an async session, which is somewhere. I guess I probably don't call it here. It's probably in the classes for extraction. But anyways, no, actually we use Playwright. We actually have to use a browser to get the data from this. Yeah, so you know what? We're going to talk about a lot of shit in this video, actually. It's probably going to be my longest video just because there's a lot of shit to talk about. All right? Aside from the analysis and deck model notebooks. This is probably my third longest video. All right, so just a heads up. Again, technical. We're going to be going through this scrape replay pipeline. I'm going to be talking about how I bypass CAPTCHA to get this JSON data from Duelingbook replays and the whole pipeline that is involved in that process. Cool. Alrighty, so I guess I was just talking about the structure of this pipeline. So again, the run pipeline entry point function is going to run this pipeline. In this case, it's going to be running this concurrency manager. And what this does is that it takes a function, right? So it takes a function to manage with these arguments, and it's going to run these functions in the way that you specify. And what that means is when I'm trying to run something asynchronously, that means many functions can run at one time if they're IO bound functions, input output network request kind of functions. All right. So this function can run concurrently, right? So these functions can run concurrently when doing this shit asynchronously. And typically you couldn't be able to control for things like how much of these functions do you want to run at one time? What's the maximum amount that you want to run concurrently? What's the rate that you want these functions to run? Like, do I want to run like 10 functions in 1 second, or 1 for 1 second, up until I reach a maximum concurrency of like 10 jobs at one time. These kind of configurations, building from scratch, uh, IO meter does that for you. All right. So again, this is a concurrency scheduler. It will take this function and it will, given these settings I have here, max at once, which is the maximum amount of process jobs that I want to run at one time, the max concurrent otherwise, and also the max per second, the rate at which these jobs are to run per second. So this is a concurrency manager that handles that, and you can basically look at that as this is a for loop that is running this function over jobs. All right, this is basically a for loop that does this with some extra stuff on top of it. All right, cool. So let me just kind of make sure that we're detached from the whole structuring pipeline thing, because this is actually a bit different from the other pipelines that we discussed with Excel and Discord. Those have, all of these pipelines is going to have a ETL kind of pipeline with extract, transform, and load. But for this one, because I have this concurrency scheduler, or this concurrency manager, and I have a retry mechanism on it as well, some things are different. All right. For this kind of pipeline, I think there are 2 pipelines like it. So let's just kind of get that out of the way. All right. So starting from the top here, I have the run pipeline function entry point. All right. So I provision what each job is going to need. Then I have this for loop for asynchronous functions, right? That runs this shit given configurations. All right. So this one function that I'm putting through this async concurrent manager, this is the actual function. So here it is, process job wrapper, and it is a wrapper over process job. You see, I have a process job function and I have a process job wrapper. The reason there's a wrapper is because we're going to be using Tenacity. Let's see here. So from Tenacity, we're going to be using them to handle our retry logic. All right. And what that means is, let's go back to process job. This is the actual process job here. You can see that it's actually very similar to the pipeline that we discussed before. This actually holds the extract logic and the load logic. There's actually no transformation logic here. So this handles the extraction and load into S3. All right. So this is the function that processes each job. And with Tenacity, you can actually place this decorator on top of a function and it can handle all retry logic. So here are some of the configurations that we can actually set up here. So this thing could retry. So if this function fails, raises an exception, whatever, it will retry. And I could actually configure the maximum amount of retries that I want this thing to run for. We'll talk about the configuration after, but at what point I want the retry to just stop. Also, you can set up an exponential wait time. So what this means is that once a retry fails, after how long do I want to initiate the next retry, right? Typically, you might see something like for a fixed amount, like for once every second, try to retry. In this case, I have an exponential retry here, which means that it'll start with a certain amount of time, and then the next after the next retry, it'll the wait race will be exponential. So it wouldn't be linear. It'll be exponential. So it'll be like, it'll have this multiplier and it'll go all the way up until a maximum retry wait time. Cool. So we have the exponential wait retry here. And then we have the retry if exception type. And what this means is that I can actually control for which exceptions do I want to trigger the retry for. And so we actually have that defined here. I have to define the replay extractor error. We'll talk about that once we get to the extract. We'll talk about that once we get to the replay extractor, the replay extractor. Yeah. Also, for any playwright errors, we'll talk about when that would be the case. And then timeout errors. We'll talk about all those in a second. But the moral of the story is, for these exception types, trigger the retry. Otherwise, just fail the job. And then some logging stuff. So, before the function even runs, or rather, before a retry starts to initiate, log it. And then after the function finishes running, log it as well. All right. So this kind of just helps with observability. Cool. So this decorator from Tenacity handles all this retry shit. You try to build this shit from scratch, is garbage. All right. So it's kind of cool that it handles all that. It works with async jobs. It works with AO meter. This whole setup I have here with Tenacity and AO meter is actually really cool. It's compact and it kind of reads nicely. All right, cool. So let's go back up here again. So we're up here in run pipeline, and we're currently on this for loop of this one function called process job wrapper. So this process job wrapper is again wrapping this process job function that has this decorator of the retry logic from Tenacity. This process job has all the pipeline logic that we've seen before, which is the extraction and the load logic, and it's in this process logic. It's in this process job function with this decorator. The reason that is being wrapped with this function process job wrapper is because whenever the retry fails, it throws a retry error. I can only capture this error if I wrap the function in this function here. So that's why that's why there's a wrapper, just to handle the retry error that the maximum amount of retries was met, this shit failed. Just mark it as failed, move on. All right. So that's why there's a wrapper. So this process job wrapper handles everything, and I'm going to do this as a for loop in this concurrency manager, and that's pretty much the end. All right. So AO meter for loop on this process job wrapper, and once everything is done, this shit is over. Cool. Everything is async, and all right, cool. So that's it. All right. So that is the breakdown of the structure for these asynchronous pipelines that's using this concurrency scheduler or concurrency manager and Tenacity. All right, great. Now we can actually talk about the logic in this pipeline. So first of all, in this run pipeline function, the first thing we do is that we set up these resources here. All right, so we set up the database session, which has to be an async database session. We set up Playwright. Playwright is like Selenium, if you know about browsers or scraping through browsers, headless browsers, whatever. Playwright is a more modern one. It has async version on there, and it's pretty good. Cool. Cool. So we set up the Playwright browser here to do our requests with. And then we also set up our S3 session, and that also has to be asynchronous as well. So now that we set up those three in this context manager, we're then going to continue with the rest of the logic here. So first thing I do is I get pending jobs. And that is this function down here. So get pending jobs, it takes in the database session. And what it will do is that it will go through my database, and it would give me 3 values per job. It will give me the league match ID. It will give me the S3 key. Give me a second, actually. Okay. So what it does is that it'll select the league match ID, it'll select the S3 key from the job table, and it'll also select the replay URL from the league match table. It joins because remember the job table, it has a relationship with league matches, right? You can see league match IDs here, and in the league match table, they have their ID here. All right. So I wanted to join by that ID because replay URL is in the league matches table. So it does all of that so that ultimately, and I also do a filter so that the job state is equal to S3 pending. So these are jobs that are ready to go, ready to start processing. I don't want to pull in jobs that are finished, jobs that have failed, only jobs that are pending. So this pulls again the league match ID from jobs table, the S3 key from jobs table, and the replay URL from league match table, which we've joined given the relationship with the league match ID. And then I also did a filter thereafter for pending S3 jobs for this pipeline. And I execute that statement, and it would give me a list of jobs with the values of league match ID. This actually should be UID. It gives me it as a UID. I don't think I find it well here, but whatever. So it'll give me the league match ID. It'll give me the S3 key. It'll give me the replay URL. Right. So that's what pending jobs does. It gives me this tuple of league match ID, S3 key, and replay URL per job in my database. Pending jobs. Great. If there's no pending jobs, get out of there. If there are pending jobs, then I'm going to initialize the extractor. Cool. So the extractor takes in the replay settings and the Playwright client. We'll talk about the replay settings in a second, but it'll take in those things and it'll initiate this replay extractor. And then with those, I'm going to provision it into the process job wrapper. You see, process job wrapper is going to take in all these inputs here. This is going to take in that initialize extractor. It's going to take in that that database session, the S3 session, and it'll take in the job data, which is going to be for the pending jobs. So I'm going to provision the job wrappers with the extractor, database, and S3 inputs. And then after with the arguments, this is what I wanted to loop over. So it's going to loop over those pending jobs. All right, cool. So let's actually start talking about the replay settings. All right. So let's go here and replay settings right here. Cool. So in our configuration, we have replay, and that's for this pipeline. So replay settings. So I've set up this configuration. If you recall from the Discord one, it's going to pull from our environment in our .env file. And these are the inputs it's going to take in. So it's going to take in SBR WS endpoint. I'll talk about that in a second, but basically we're going to be using a service to bypass CAPTCHA here, and it's called Bright Data. We'll talk about them once we get to the extractor class. The next one is the screenshot directory. So this is the directory. So whenever a scrape fails, I actually want to take a screenshot of the browser and what happened, what kind of error it threw at me, so that I could keep that. All right, cool. So screenshot directory for fails, and then next one, the S3 prefix. So yeah, so in my S3 class, I have a utility class for S3 to do my gets and my or to push and pull data from S3, and it needs a prefix. This is basically the folder. So this is the prefix of the folder of the replay files in S3. So in this case, the folder is GWFL. All right, and then page timeout. So this is a playwright configuration. We'll talk about that once we get to the replay extractor. And then we have retry settings. So this is the tenacity settings that we were just discussing. So the retry mechanism, logic, those settings. So the maximum amount of retries, the exponential minimum weight, exponential max weight, exponential multiplier. And then we have the AO meter settings. So this is the concurrency manager. So how much do I want to run? How much jobs do I want to run concurrently at one time? And what's the rate that I want these jobs to run at per second? And these are the settings that I have set up here. So for the screenshot directories and the screenshots, location, the prefix. So the bucket is actually GWFL in S3, but the prefix or the folder is actually called replays. This is the thing that ended up prefixing everywhere, and I talked about it a few videos ago, or last video, I don't remember, but I had to deal with that here. Then I have page timeout. So in Playwright, which is the browser that I'm going to be using to make requests to Duelingbook, when a request is made to Duelingbook, there's some logic in the extractor that waits for certain elements to be rendered. And once these elements are rendered, I could pretty much be assured that I bypassed CAPTCHA and the data is available. So what page timeout does is that it'll wait for these elements to show up until there's a certain amount of time. So this is in milliseconds. So that's why it's 10,000 or 1,000 times 60. This means after 60 seconds, you could throw out the timeout error. All right, cool. So this is also one of those errors. If this thing passes 60 seconds, this will throw that timeout error, which we're capturing in our retry mechanism. All right, cool. So maximum retries after three retries, fail it. And these are the exponential wait time settings, and this is the concurrency stuff. So I want to run 30 at one time. I've never actually made this higher. You could make it higher. We'll talk about Bright Data in a bit, but from what I've read in the documentation, is that they don't have a limit for how much you can run at one time. Bright Data is built for enterprise, is built for places that want to scrape fucking Amazon and shit like that. So like, I could probably do a lot more, but I haven't felt the need to. This thing ran pretty quickly for 4,000 replays. So you could put this higher. And the next one is the max per second. I put 2. You could also probably put that higher. All right, great. So that's the replay settings. Okay, so let's start looking at this from top to bottom here. So as we were just in, so we got the pending jobs, right? So we got the pending jobs. Afterwards, we set up the extractor. Okay, and we give it our replay settings and the Playwright client, our browser client. And now we're looping through this process job wrapper. If we look at process job here, the first thing it does is that I forgot the word, but some kind of unnesting of the tuple. So now I have the job ID, S3 key, and replay URL as strings, or except for the ID. This should be UID. But I've unnested that, I guess, from the tuple. And next thing I do is that I await from the extractor. I call this method extract replay JSON. So now let's actually look at this. All right. So this is the replay extractor. All right. This is how I set up Bright Data and get the JSON from replays. All right. So let's look at this. So we can see here in the initialization that I've gave it the configuration and the playwright client from the run pipeline function. The next thing I do here is I call this method here extract replay JSON. And what it does is that it takes in the replay URL. All right. So it takes in the URL that it wants to extract the data from, and let's see what it does. So first thing it does is that it'll use the playwright client, and it'll connect over CDP. So it'll connect to the WebSocket endpoint that we got from Bright Data. So now we can talk about this. So first of all, it creates a client. No, it creates a browser client connected through the WebSocket endpoint that we got from Bright Data. So let's look at that. Okay, so Bright Data. All right, I think it's maybe this one. Let's actually just look at Bright Data altogether. So Bright Data, right? Limitless web data infrastructure for AI and BI. All right, so this is like, people talk about. Let's talk about capture real quick and all that. So with Duelingbook and replays, there used to be no CAPTCHA, but now there's CAPTCHA. And the CAPTCHA version that it has there, it has reCAPTCHA from Google, and it uses a combination of V2 and V3 CAPTCHA. And what that means is that V2 is you have those puzzles, right? You trigger a puzzle, and then you have to solve the puzzle and whatever. And then for V3, that is a non-interactive one. Basically, what V3 does is that, so I'm a client here on my browser, and I'm going to go to duelingbook.com, and my fingerprint is going to be available for reCAPTCHA, and V3 is going to look at my fingerprint and it's going to say how likely it is I'm about or not based on my past interactions with a website. So if I've solved V2 a few times before, and it knows that my fingerprint is of human or whatever, V3 is going to say it'll give Duelingbook a score of like, all right, this guy is like 70% human, whatever, something like that. And then Duelingbook could decide based on which threshold to give it a V2 challenge again or something, right? So that's kind of a summary of reCAPTCHA, Google's reCAPTCHA, V2 and V3, and how Duelingbook has that set up. Cool. So Bright Data is an enterprise level way of bypassing those kind of data. And the ethical side of it is kind of a long-standing one. Basically, there used to be a lot of talk back in the day, or a bit recently. There's a lot of drama about Twitter and how all of these AI services was scraping from all over the internet, and Twitter was filing lawsuits and all these things, and the scrapers won that lawsuit because anything that's publicly available should be able to get scraped from. And publicly available means that you don't have to log in to get that information. So whether or not you put on your robots.txt that is against TOS, you can do whatever. In court, scraping publicly available websites have been winning, basically. And so that's kind of how Bright Data has its legs here. Basically, there's big demand to get data from places like Twitter, from LinkedIn, whatever, job postings, all these things. So, Bright Data is that service that uses mostly machine learning and AI to bypass CAPTCHA. It's kind of like an arms race between Bright Data solutions for reCAPTCHA and reCAPTCHA itself. And this is that solution. This is the number one solution that all the big companies uses. All right. So Bright Data actually offers a lot of services here, right? So it offers proxies, it has really good proxies here. It also offers scraping, so you could do you could do scraping stuff, without code, or you could go through their WebSocket endpoint. You could use their browser. You could use all kind of things, right? They have all kind of products when it comes to scraping and proxies and whatever. All right, cool. So the one that we actually end up using, I think it's the Web Unlocker. I don't recall. But basically, um, Yeah, so effortlessly bypass advanced bot protection to ensure unmatched success rate and scale your scraping without limits. All right, cool. So for about 1,000 requests, cost about $1. All right, and you pay for successful delivery. So if this thing successfully bypasses CAPTCHA after about 1,000 requests, you get about $1. Actually, I'm actually not sure if this is a product. I ain't gonna lie. Let me just look at Web Scraper. You can see here some of the examples that have CAPTCHA that Bright Data is usually good about getting stuff from. So like apartment listings, LinkedIn job stuff, social media stuff, Instagram, all that. All right, you know what? I think I'm gonna roll with it with the web unlocker. Yes, so I'm gonna roll with the web unlocker. It could be scraping browser actually. Okay, you know what? I think it's this one. This one. It's scraping browser because we're going to be using a browser. We're going to be using a browser client to interact with this. All right. So I'm not going to have I don't have a pipeline or I don't have a diagram here, but let's see here. A browser, WebSocket, proxy, a diagram. Yeah, I mean, if you're familiar with a proxy, basically, like this is me. I'm the browser, and I've set up the browser with Playwright, right? So I set up a Playwright, but through Playwright, I'm configuring it to first go through Bright Data's web WebSocket endpoint. So it's going to go through Bright Data. Any request that I want to make, it'll take the information, it'll go through Bright Data first, and then Bright Data would use their infrastructure to actually get that data from my target URL, which would be Duelingbook in this case. And once it gets that data, then it'll return it back to me, right? So this is kind of how it works. Disregard this other shit. All right, cool. So this is the scraping browser that does that. Alrighty, so you can see here that it says so see you can run your different browsers scripts. So Puppeteer, Selenium, Playwright. You can automate all this shit. You could use the dev tools, kind of cool. You could fully hosted browsers, optimized for scraping, all that. Yes, this is it actually. So this is the Playwright stuff. You can see this is an example of a web. I keep forgetting the word. WebSocket endpoint, right? So you can see that there. You have to connect over CDP. So now your browser is connected through Bright Data, and then you can make the request as usual, as normal. And now everything's going through Bright Data. Cool. All right, so you have high success rates. You have boosted whatever, all this other shit, right? So it has the browser fingerprinting, captcha solving, cookies, whatever, IP, all that. All right, so you actually have to pay per gigabyte of stuff. So I didn't pay much for 4,000 replays. Um, yeah. So I actually needed to go through this route, and I couldn't just go with the web unlocker. The difference between scraping browser and web unlocker is that for web unlocker, you would use an HTTP client, right? So I could just call, make a request to Doodlebook, whatever, and give me the JSON if it was a JSON endpoint. Um, but for this browser shit, I've actually had to go through things a bit differently because Duelingbook. Let me see if I could. Probably can't. Um, all right. So check this out, right? So this is an example of a replay. And if you go to the network tab, look at all this garbage, man. I can't believe this waterfall, but I want to refresh that because I want to resend the request. So look at this, right? This is the endpoint that you would typically use if you wanted to use web unlocker. So in this endpoint, you can see here it goes to this view replay route with the ID, and if I were to go through here, it will give me missing token. All right, it'll give me missing token, and that's because this have changed how it used to be. Before this would make a get request to this URL, and it'll just give you the JSON. And the JSON in this case looks like this, right? It looked like this. This is the JSON right here. Well, all the replay data here, right? Now it's a post request because what this post request needs is using v3, and it's not using, and v3 is difficult. You can still do it as I have, but you can't do it simply with like a GET request that has a captcha on it that gives you JSON, like you would use if you're using another product from Bright Data, like the web unlocker. I have to actually use the browser because the replay JSON that I'm going to get from is not going to be through this endpoint. All right, I actually have to get it through the console. So in the console, you can actually see that the JSON is printed to the console here. This is the actual JSON here. The whole thing is here. So instead of having to deal with making a post request to this view replay, whatever, in the payload you can see this token here. This is my capture version 3 token, right? So like this is generated once I make a request to replay ID. It will give me a v3 token, of which then it'll make a post request to view replay, and then it'll validate that token on that side and whatever. To do things more simply would be I still go through this replay URL, and I would check to see if the replay is loaded. If the replay is showing, then the JSON is loaded in and everything. And once that is loaded in, I could actually just go in the console log here, which is one of the big benefits of being able to access the dev tools or whatever, is that I could actually go in the logs here, and I could actually just look for a message that contains the JSON and just pull that. So that's a high level overview of how we're going to do this extraction and Bright Data's role in doing that. So Bright Data's role in doing that is that I could give a URL, and it could give me the result after bypassing captcha. All right. So it could get me to the point of right here, the replay is running. The next step would be to get this replay JSON from the console. All right. So that's a high level review, and that's how Bright Data is coming to play there. All right, cool. So let's go back to the extractor in the file. All right. So first of all, we set up that Bright Data WebSocket endpoint. Cool. So now the browser is going to be going through Bright Data. So the first thing you have to do is you have to create a new page, like a new tab. Right. So I call it a new page, and you don't want to immediately go into the Duelingbook URL. And the reason is you have to do some setup first. Like for you to set things up where I could go on the console and pull in that data, I have to do something first. And the first thing I do is that I have this empty page, and I'm going to inject a script in that page. And this is the script that I'm going to add. So I'm going to overwrite the console.log function in all the websites I go onto, and I'm going to rewrite it so that whenever this function is called, it's going to push in the message into this console.log's global array. It's going to push that stuff in there, and then it's going to apply the original log, which I've kind of saved here. You see? So I'm going to run this script, which overrides console.log so that it can save all log messages into this global function here from Windows. All right, cool. So I'm going to make sure that this thing is ran. I've overwritten the console.log function, and I'm going to be saving all messages now, printed to the console. So now we're going to get into the actual Duelingbook stuff. So I'm going to actually go to the replay URL, right? So again, this method took in the replay URL link. So it'll go to the replay URL. I have a timeout here, and I'll wait until the content is loaded. So I'm going to wait for this. All right, and I'm going to give it this timeout. All right, so once the page is loaded, what happens next is I'm going to wait for this element to show up called this div element with the card class. And once this element shows up, that means that the replay is running. It has the data, and the actual replay is being played out. You see? So once this element is running, well, first I'm going to wait for this element, and I'm going to wait for my timeout here. So I'm going to wait for the timeout and all that. All right. If this thing passes the timeout, which is set at 1 minute, if it passes the timeout, then it's going to throw this timeout error. And once this timeout error is raised, I'm going to take a screenshot of the page. I'm going to save it to my screenshot directory. And I'm going to, raise the error so that the retry mechanism with tenacity in the pipeline could handle that. All right. But if this page is loaded and the div card is, visible, Bright Data at this point is already working and is already bypass captcha. Once Bright Data has done that, then I'm going to execute this JSON in the page. So I'm going to get the log from the console logger. So in the page, I'm going to evaluate this code on the browser, which is I'm just going to call the array that I've made up here. So you can see here window.console.logs or window.console logs is this array, which now have all the logs that have been printed since I've went into the Duelingbook replay. All right. So it's going to execute this array, which will return me the console logs as a list of strings, I think. So it'll give me a list of strings of the console messages. That's my console logs. All right. So in between the time that I went to the Duelingbook replay and I've waited for the replay to start running, aka the data is available and have been printed to console, I now pull the logs from that replay, and now I have this list of messages here, list of logs. If there's no logs, this never happened, but this is like validation. If shit didn't work out, take a screenshot, whatever. Move on. So this never happened because the expected thing is stuff is being printed to the logs. At this point, I know it has bypass capture and the replay is showing. So at this point, again, I have this list of console logs. So the next thing I run is this method here, extract JSON from logs. So I give it the list of logs, and I'm going to extract the JSON now from it. So again, console logs is a list of strings, and the extract JSON from logs method, what that is going to do is going to go through each message in the console logs, and it's going to attempt to load each string as a dictionary. So for it to load successfully as a dictionary, it has to be in the same form. It has to be in a JSON format. All right. So it has to be in a JSON format. So if the message is in a JSON format, then I know that it is very likely to be the replay JSON that's been printed to the log. If it is not, if this thing is not parsed correctly, it'll throw this JSON decode error, which means that it's not a JSON, and just to continue throughout the rest of the logs in the console. All right. So cool. So at this point, the data is decoded as a dictionary. Okay. So now I have the dictionary of the replay JSON, and now I'm, just to make sure that it is the actual replay, the replay JSON that I want. I would check to see that it is a dictionary and that it has the conceal key in it. And this is just verification that I've already closed it out. But this is verification that this is the replay JSON that I want. And so once it passes validation, just return the JSON. All right. So that's pretty much it. That's the whole extraction process, just from the top to bottom. What I did was I initialized the browser and the page. I connected to Bright Data, and then I added this script which overwrites the console.log function to make it so that it's being stored in a global array. And then once that is done, I'm gonna go to the replay URL. I'm going to wait for Bright Data to do its thing. And then once this thing is bypassed and everything is good to go, I'm going to pull in the logs from the array. And then once I have the list of logs, I then try to find which message has the replay JSON, and then I extract that. Cool. Alrighty, that's it. That's the extract replay JSON method extractor and all that. So at this point, I have the replay JSON as a dictionary. All right. So now I have it as a dictionary, and next thing I'm going to do, I'm going to try to load the results. All right. So I'm going to call from my S3 client. I'm not going to show the S3 client. I'm pretty much just messing with the Boto 3 API AWS client there. So it's pretty low level to the API if you know about AWS. So I'm pretty much just going to put this object of the replay JSON dictionary into this S3 keys of replay/S3 key. So in this put object, you can see here it takes in the key, it takes in the object, which is the replay JSON in this case, and then file type. So depending on whether this is a JSON or CSV, it has to turn it into bytes a bit differently. And the whole process for that, I guess I can show that. You can see here in this S3 here, if it is a JSON, then I call this serialized data client method here. And if it is a JSON, it goes through the serialized JSON thing. It'll turn this thing into to what I need and encodes it and everything. And it gives me the correct application JSON, everything that I need to put the object into S3 as a JSON object. Cool. So kind of brush over that. You don't have to know much about that. If you know about AWS and whatever, it's fine. If you don't, you could just save this into your local PC as a JSON file as well. All right, cool. So next step here. So if this put object load is finished, once this thing is finished, it would give me a result. This result would be what AWS gives me, like details about the put. If the put failed for whatever reason, it will give me none. All right. So if I got results, which means that this thing is successful, then I want to update the state of the job as completed. Otherwise, have it as pending. I think it should be failed. This probably should be failed. But anyway, so whether or not this thing is, oh, actually, yeah, sure, pending, because I mostly care if the replay extraction failed, not if not if there's an issue with the S3 client, because if there's an issue here, is it's my fault. So and I want to retry that a bit later. So I guess completed or pending is the new state, and then I'm going to update the job with that state here, basically, and commit the changes to the database. All right, so that's process jobs. So this is going to, again, run that process job function through all the pending jobs, and then once everything is done, that'll be the end. And the output of this is that all of the jobs in the database is going to have either completed or failed, and S3, my S3 is going to have all the replay JSONs with the keys that's defined in the job table. So that's it. That's the run, scrape, replay pipeline. We just talked about how I used Bright Data and whatever to get the replay JSON from Duelingbook replays. And I have this pipeline here with a combination of asynchronous stuff and tenacity retry mechanisms to, extract the data and put it into S3. Cool. So the next video, we're going to get into the next stage here, where we're going to talk about deck type modeling. All right, so this is a classification model, some data science stuff. We're going to be, so at this point now, okay, no. So at this point, we need to make the model first. So we need to make this deck type model first. And we're going to need that because once we start parsing the data that we just extracted, this replay JSON, once we start parsing that, I want to have the deck type prediction from my model already made there so that whenever I load the database, everything is ready. So this is kind of this caveat step where I have the JSON now, but I have to finish making this deck type model so that I can make predictions for deck type and all that. So we're going to go into stage 3, and I'll catch you on the next video.